Okay, we have here three swimmers that can swim fast relative to water. And what we are told, they have a race to see who can swim across a river in the least time. Relative to the water, Beth swims perpendicular to the flow. Anne swims upstream and Carly swims downstream. Which will win the race? So you notice here at the bottom we have the river and we have Carly here, Beth here, and Anne here. The question, which will arrive first? What's going to matter for crossing the river is the velocity perpendicular to the river, the velocity along the y-axis. So Vy for A is going to be this component of A. Vy for C is going to be this component of V. So you notice that B has a larger velocity along the y than either Anne or Carly. So the winner in this case is Beth. The next question is, now that Beth wins, who gets across second, Anne or Carly? Now again, very much like we discussed before, notice that here both of them have the same y component of the velocity. Since both of them have the same y component of the velocity, we expect them to arrive the same. It's a tie. Okay, let's quantify this. In this particular case, they are asking us what angle should Anne take to get directly to the other side if she can swim 5 miles per hour relative to the water, and the river is flowing at 3 miles per hour. So the river is flowing this way at 3 miles per hour. Anne can move at 5 miles per hour, and she has to move somewhat at an angle so she can arrive directly to the other side. The question is, what angle? This angle here, we need to find it. The velocity addition formula, it says velocity of Anne relative to the ground is equal to velocity of Anne relative to the water plus velocity of water relative to ground. Now, for Anne to move straight to the other side, for her to move directly to the other side, that means that Vn relative to ground, I'm not going to write the full word, along the x should be equal to 0. But what's Vn relative to ground? Vn relative to ground along the x is Vn relative to water along the x plus V water relative to ground along the x. V water along the ground along the x is given. That's 3 miles per hour. This is our unknown. This is going to be 5 miles per hour times, it's going to be this, times the sine of theta. And you notice here the negative direction, of course. So we have minus 5 miles per hour sine of theta is equal to 3 miles, plus 3 miles per hour is equal to 0. Or sine of theta is equal to 3/5. And you just do the inverse sine, which should give us as 36 0.8 degrees.